Hello everyone. Okay, today's lesson will be about factoring the special cases that we talked about, it feels like a year ago, but it was back in 8.4, the last section before the last test. So first, if you'll recall, if you have a binomial and it's being squared, what results is a perfect square trinomial. Okay, so I gave you two examples here to remind you. Quantity 4n minus 7 to the second power, and then I did all the work, and then also quantity 6x plus 1 squared. Okay, so I put the big green stars because these two are what we call perfect square trinomials. Okay, now how do you recognize a perfect square trinomial? Well, the first and the last terms are perfect squares. The middle term is 2 times the product of the square roots of the first and the last term. So if you look up here at these, it always turns out whenever you're squaring a binomial that your outer and inner are exactly the same. So it's like twice that, okay? So that is how we recognize a perfect square trinomial. Our other special product was the result of the sum and difference pattern. Okay, so when we multiply a sum and a difference, which means everything's the same except for the sign between, our answer is called a difference of squares. What happens is that the outer term and the inner term are opposites, and opposites always add up to 0, so therefore we do not have the middle term. So how do you recognize a difference of squares? Okay, so remember what we're talking about is the answer here. So how do we recognize that? Well, the first and the last terms would be perfect squares. There is not a middle term, which is that bx term. We don't have that term. And finally, and this is one that you need to really remember, is that it must be a difference. So there has to be a minus sign between the two terms. So therefore, this is a difference of squares, but this is not a difference of squares and would not be factorable. All right, so here's the first of 3 examples. Remember, the first rule or first thing that you should always look for is a greatest common factor. So, do these 3 terms have a greatest common factor? Okay, and then the next thing is, since we don't know how to factor quadratic trinomials where a is not 1, then now you need to start thinking, okay, is this a perfect square trinomial? So remember, you want to look at the first and the last term, and are these perfect squares? Yes. The middle term must be twice the square roots of these. What I just say is if those two are perfect squares, go ahead and factor it out to C, and then you can always check it, okay? So the way that you'll know what the factors are is what is the square root of this? Would be 8x, so those are your 2 first terms. And then since the middle term is positive, both of them will be positive. And then what is the square root of the last term? It's 3. So the only thing we need to check is that we would get this. So if we multiply, oh, I forgot to put 3 here. If we multiply 8x times 3, that is 24x, and 24x times 2 is 48x. Okay, so it does work out. So you can write your answer as this, but the simplest way to write this answer is quantity 8x plus 3 squared. Okay, here is our next example. So a lot of people just kind of go straight here and notice that those are perfect squares and want to start factoring, which is fine, but they neglected the first step in all factoring, okay, which is to check to see if there's a GCF. And this does have a GCF. So what is the GCF that we can factor out? It is 25. So 25 times the quantity, n squared, minus 4n plus 4. Okay, once we've done that, then we will, the 25 is just a monomial, so it's not going to factor any further. So we'll just bring it down, but we're going to see if we can factor this. And this is a perfect square trinomial because n squared is a perfect square, and so is 4. So we're going to see if that is what it is. So n minus 2, because the square root of n is n and the square root of 4 is 2, and then n minus 2. And it's minus minus because the middle term is minus, okay? And then you can just do a quick check. Negative 2n does make negative 4n. So the simplest way to write this final answer would be 25 times the quantity n minus 2 squared. Okay, our final example today is 112d squared minus 63. So this right away, hopefully you notice, does not have a middle term. However, the 112 and the 63 are not perfect squares, but we should always start by asking ourselves what when we are factoring. We should be asking, does this have a GCF? Okay, so what is the GCF? It is 7. So if we factor out the 7, we get 7 times the quantity, 16d squared minus 9. Okay, from here, the 7 is fully factored, so we just look at this quantity and think, can we factor that further? Well, it is a difference, and it is a difference of perfect squares. So we bring down the 7, and since it's a difference of perfect squares, we can factor it. So what is the square root of 16d squared? 4d. So those are our two first terms. And the only way to get a 0 middle term is if one of them, if we get opposites for the outer and the inner. So that means one of these needs to be plus and one of these needs to be minus. And then the last term in the two binomial answers is the square root of 9, which is 3. And you can do a quick check. 40, 40 times 40 would give us 16d squared. 3 times negative 3 is negative 9. 3 times 4d is 12d. The inner term, the outer term is negative 12d. So it does add up to 0. And that is our final answer.